Hi, I'm Tom Zanton, and today I'm going to be talking to you about why I think that fiber is a nutrient actually. There's a lot of talk about this recently, especially among the carnivore and ketogenic community, and I just wanted to throw thoughts out there because I don't really understand the talking point that people are putting forth. So, maybe if I put my thoughts out there, someone else can put their thoughts, give their thoughts back to me. Maybe we can help clear this up a little bit. Um, so yeah, so I think fiber is a nutrient for two main reasons. I think that the right type of fiber from the right type of plant will do two things for you. One, it will feed your good gut bacteria, and two, it will flush toxins out of your body. So let's talk a little bit about what I think the right type of gut bacteria is, because it's all dependent on what the right type of gut bacteria is, and then you need the right food for that specific gut bacteria. So to me, what seems logical for the most likely the natural inhabitant of the human gut is a type of gut bacteria called bifidobacteria. A healthy breastfed infant's gut will have over 90% bifidobacteria, which I think is really interesting. So they get it, the infant gets the bifidobacteria from a few different places from the mother. They get it from mother's vaginal tract, gastrointestinal tract, and there's bifidobacteria in the breast milk itself. And on top of that, the human breast milk actually feeds bifidobacteria pretty much unlike any other food on the planet. It might be, the or one of the most bifidogenic foods out there. So for those reasons, the redundancy built into colonizing bifidobacteria plus feeding it with one of the most bifidogenic foods, it seems like bifidobacteria might be the natural inhabitant of the human gut, at least for most people. I'll talk about that another time. So, if they are the natural inhabitant of the human gut, you would expect them to do a lot of things for you. So, what do they do for you? So, if you feed your bifidobacteria, they will produce a number of essential nutrients for you. Not that you can't also get these from your diet, but it helps to have a backup source for some of these. And for some of them, it's the only source, or one of the best sources. So one of the things that bifidobacteria will produce is short-chain fatty acids like acetate, butyrate, and propionate, and these are important for a whole bunch of functions in your gut. And when I looked, short-chain fatty acids, the more of them you had, the lower your risk of death from 8 of the 10 leading causes of death. So it's good to have short-chain fatty acids, which bifidobacteria will produce. Bifidobacteria will also produce B vitamins, B1, 2, 3, 6, 7, 9, and 12. And the ones I think are most interesting, maybe from an evolutionary standpoint, which is what I like to talk about, are folate and thiamine, and I can talk about those in more detail another time. Bifidobacteria will also produce certain amino acids, proteins, like methionine, threonine, leucine, and lysine. These are some of the very amino acids you might expect would be a little bit low on a plant-based diet, or mostly plant-based diet centered around root vegetables. I think that's very convenient. On top of that, bifidobacteria can produce an anti-aging compound called spermidine. Bifidobacteria, there's suggestive evidence that it can produce BDNF, brain-derived neurotrophic factor, which helps stimulate nerve and brain cell growth. This hasn't been directly tested in humans, meaning they haven't given people like bifidobacteria probiotics and then tested their BDNF. But they have done that in mice, and then they have given people fiber and then measured short-chain fatty acid production, which could be seen as like a proxy for good gut bacteria like bifidobacteria, and then they've tested their BDNF. So if you give someone fiber and then their short chain fatty acids go up, then their BDNF will also go up. So it's suggestive evidence. It's not necessarily rock solid yet. And then also bifidobacteria will convert vitamin K1 and ALA, plant-based omega-3 fatty acid, into vitamin K2 and omega-3 fatty acid DHA, which your brain needs. So, you go down the list, that's a lot of things that bifidobacteria will make for you if you feed them. On top of that, there are a number of things, mostly minerals, that bifidobacteria will actually help you absorb. Bifidobacteria will help you absorb iron, calcium, magnesium, zinc, iodine, and folate. And those are a lot of the nutrients, those are a lot of minerals that people tend to say, well, a lot of people don't tend to get enough of those, but it would be helpful if people had more bifidobacteria, which seems to be the natural inhabitant of the human gut. And if they did, they would have an easier time absorbing all of those minerals and folate because of the higher concentration of bifidobacteria. And then, furthermore, bifidobacteria actually helps you break down or mitigate the risk of certain toxins or things that you don't really want a lot of, such as fluoride, anti-nutrients like phytates and oxalates, and also uremic toxins. And then bifidobacteria can help metabolize heavy metals like arsenic, lead, mercury, and cadmium. It can help flush out estrogens and endotoxins. And I put it all the way at the bottom of the list because I know some people don't care about this. But in case you do care, bifidobacteria will help you basically flush out cholesterol from your system. So that seems to be a lot of things that bifidobacteria will do for you. And I hope that most people agree that most of those, if not all of them, are really good things to have happen. But there's a problem. The problem is that people tend to lose most or all of their bifidobacteria once they switch to their adult diet. And generally, the more bifidobacteria you lose, the less healthy you tend to be. And bifidobacteria is absent or in very low levels in people with IBS. But even when you do have really low levels, bifidobacteria are considered a keystone taxa for your gut, essentially meaning that even at low levels, they do an outsized portion of work for you, producing things that you need. But the question is, if they're so important, if they do so many things, why do bifidobacteria get so low? I mean, presumably it's because, just like any other type of living organism, bacteria need food to thrive, and they're stuck in our gut. So presumably we're losing them because we're not feeding them. And you have control over whether or not you feed them. So, just to kind of wrap this all up, what do bifidobacteria eat? Bifidobacteria seem to do really well with starch, which is found in starchy root vegetables. There was a study where they took 25 strains of bifidobacterial species, and they tested for a starch degrading pathway in those 25 strains, and they found a starch degrading pathway in all of them. So it seems like bifidobacteria is made to eat starch. I even saw one study that showed that it handles digestible starch better than resistant starch, which I think is interesting. Bifidobacteria also does really well on a type of fiber called inulin. And inulin is abundant in several root vegetables, other foods too, but several root vegetables like onion and garlic, radishes, jicama, and sunchokes or Jerusalem artichokes, which are not a super common food. But it's another root vegetable, and there are more examples. So I think that's interesting that bifidobacteria do well on the type of calories and the type of fiber found in a lot of root vegetables. On top of that, bifidobacteria actually do really well with lactic acid bacteria, even heat-killed lactic acid bacteria. So even if they're not live probiotics, these are the type of bacteria that tend to be found in pickled vegetables. So they like to grow on the simple sugars found in vegetables. And there's a reason why I think that this actually pairs pretty well with root vegetables in a burned habitat, and I'll get into that in another video. That would take too long here. Bifidobacteria also do really well on some plant polyphenols, especially anthocyanins, which are found in berries, but also in reddish purple varieties of vegetables. The anthocyanins are actually pigments. They're reddish, purplish, bluish pigments based on the acidity of the food. And a number of them are found in root vegetables. There are varieties of reddish, purplish foods in root vegetables, like purple and red potatoes, purple sweet potatoes, red onions, purple carrots, radishes, and turnips. So it's important to keep in mind that all of these things are found in, or growing on, in the case of lactic acid bacteria, root vegetables. They're all found in root vegetables. It's the calories, the fiber, the bacteria that grows on, and the color of root vegetables. And I know they're not all the same color, but these are all things that can be found in root vegetables, which I think is really interesting, that the natural inhabitant of the human gut seems to be made to eat all the things that you would find in root vegetables. So if bifidobacteria is made to eat root vegetables, and they're the natural inhabitant of the human gut, then you might assume that humans are also made to eat root vegetables. So first of all, I want to say that I understand, I think I understand at least part of why people will say, well, fiber is not a nutrient. Because we're in a society that where agriculture is kind of the default for some obvious reasons, we tend to think of fiber coming from grains, and obviously there is fiber in grains. But just because that's our default option of thinking fiber comes from grains, that doesn't necessarily mean that it's the only fiber option, that is the only that bacteria that eat grains are the only types of bacteria that could be in an animal's gut, even one that eats plants. So if you have an animal that eats plants, it's not necessarily going to break down grain fiber unless it's actually made to eat grains. And I would argue that maybe we're made to eat small amounts of grains, but I think mostly we're made to eat root vegetables, which will feed the good gut bacteria in our guts how they're supposed to be fed. Will actually keep the bifidobacteria that we're supposed to have there, and they'll do all the work for us that they're supposed to do. So let me know what you think. I know this is not the typical argument that you hear from people, so I'm sure I'll get people who comment and say that I'm crazy, and that's fine. But I think that there's at least a certain logic here. There's a certain, it makes sense in a certain way. So I would love to hear what people think. I'm sure I'm not necessarily going to convince anyone, but hopefully I'll at least give people something to think about. Until next time, I want to thank you for watching, and I hope you like and subscribe. And if you do want to comment, please leave a comment. I love responding to comments. Just try to keep it nice, I guess. But and I will too. But I guess that's it. So thank you for watching. Bye.